I'm Joe Graydon.
And I'm Terry Graydon. Welcome to this podcast of the People's Pharmacy.
You can find previous podcasts and more information on a range of health topics at peoplespharmacy.com. COVID cases are dropping, but the variants are scary. How well will the vaccines work against these new versions of the virus? This is the People's Pharmacy with Terry and Joe Graydon.
Revving up the pace of vaccinations is exciting. In Israel, where many people have been vaccinated, hospitalizations, severe illness, and death are down sharply. Cases are also falling in Europe and in the U.S.
Today on the People's Pharmacy, we're talking with two of the world's foremost authorities on vaccines and the coronavirus. What do you need to know?
Prevention is critical, but what about treatment? We'll discuss new drugs for COVID-19. How do we stop the next pandemic?
Coming up on the People's Pharmacy, COVID-19, vaccines and variants.
In the People's Pharmacy Health Headlines, COVID-19 cases are falling at encouraging rates. Once Americans got past the holiday travel season and the resulting surge, new infections have declined. Hospitalizations and deaths are also declining. Cases are down by almost 25% in the last week. Scientists are not entirely certain what accounts for the dramatic reduction. Some possibilities include a cutback in close person-to-person interactions, the beginning of vaccination, and an increase in the number of people who have recovered from infection.
Worldwide, coronavirus cases are dropping by about 16%. India is experiencing plummeting caseloads. In September, the country was reporting nearly 100,000 new cases daily. Now, the number has dropped steeply to about 11,000 cases. Hospitalizations are also down. The country has only recently begun to get their vaccinations underway, so it's unlikely that the reduction can be attributed to the vaccine program. Some experts suggest that the country could be nearing herd immunity. That seems unlikely, though, because the seropositivity rate is roughly 20%, well short of the 70 to 85% required to accomplish such protection. Others attribute the decline to mask wearing, which has been mandated by the Indian government. Whatever the reason, public health authorities warn that danger still lurks around the corner. Variants of the virus could trigger another wave of infection.
SARS-CoV-2 has been mutating, and the result is a growing list of virus variants. In addition to those first discovered in the UK, South Africa, and Brazil, American researchers have identified 7 new variants in different parts of the country. All 7 of them appear to have independently acquired a specific mutation that changes the protein on the coronavirus spike. Scientists don't know what type of advantage that mutation may confer, but seeing it evolve independently suggests it does offer the virus an edge. Experts say the emergence of so many variants means it's more urgent than ever for people to get vaccinated.
How effective are the COVID vaccines at preventing illness? That's a question Israel has attempted to answer with a large study. Investigators evaluated 600,000 citizens who were not immunized, compared to 600,000 Israelis who received the vaccine. What they found was heartening. Those who were vaccinated were 94% less likely to develop symptomatic COVID-19 infections. These results are in line with the clinical trial data submitted by Pfizer-BioNTech. Israel has already vaccinated over a quarter of its population, putting it far ahead of any other country. Health officials plan to inoculate almost the entire population by March. Hospitalizations, serious illness, and deaths have been dropping dramatically in recent days.
There's a new study about the role of vitamin D in the fight against COVID-19. Investigators at the Hospital del Mar in Barcelona, Spain, report on a study of 930 COVID patients admitted to their facility. About half were assigned to vitamin D3 treatment, while the others did not get the supplement. The protocol called for 532 micrograms, which is 21,280 international units, of vitamin D3 on the first day, and 266 micrograms on days 3, 7, 15, and 30. The results were striking. About 5% of those getting vitamin D required intensive care, compared to 20% of those who did not. In addition, 6.5% of the vitamin D recipients died, in contrast to 15% of the control group. The researchers conclude, in patients hospitalized with COVID-19, calcifediol treatment at the time of hospitalization significantly reduced ICU admission and mortality. The study has not yet been peer-reviewed, and some COVID researchers are skeptical. They suggest that the statistical analysis used is incompatible with the randomization method. Further research will be helpful, but vitamin D3 at such doses is not harmful. And that's the health news from the People's Pharmacy this week.
Welcome to the People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon. COVID cases are declining in the U.S. and in Europe. It's not clear exactly why, and no one knows what the coming weeks will hold. The virus has developed a number of variants, and some of them have caused serious surges in the UK, South Africa, and Brazil.
In the U.S., scientists have identified 7 variants that have seemingly evolved independently. They've named them after birds, such as robin, pelican, bluebird, and quail. We don't know if they'll prove to be more transmissible than the original version of the coronavirus.
Today, we're talking to 2 of the world's leading authorities about COVID-19 vaccines and variants. They'll give us some sense of where we are and where we may be heading. Later in the show, we'll talk with the coronavirus hunter, Dr. Ralph Barrick. He's been studying coronaviruses for more than 3 decades, long before SARS-CoV-2 emerged.
First, though, we're talking with Dr. Paul Offit. He's the director of the Vaccine Education Center at the Children's Hospital of Philadelphia, as well as the Maurice R. Hilleman Professor of Vaccinology and a Professor of Pediatrics at the Perelman School of Medicine at the University of Pennsylvania. Dr. Offit is the author of several books, including his most recent, Overkill: When Modern Medicine Goes Too Far.
Welcome back to the People's Pharmacy, Dr. Paul Offit.
Thank you. Pleasure to be back.
Dr. Offit, there's good news and bad news on the vaccine front. There is a new vaccine under review at the Food and Drug Administration for emergency use authorization from Johnson & Johnson. Can you tell us a little something about it, please?
I know what you know, which is what I've read from press releases. It appears to be 72% effective at preventing moderate to severe disease in the United States, 57% effective at protecting against moderate to severe disease in South Africa, where the South African variant is prevalent. However, all in all, supposedly, it is highly effective against the kind of disease that causes you to be hospitalized or to go to the ICU or to die. So that's good. But again, I just want to emphasize that when we review this at the FDA's Vaccine Advisory Committee on February 26th, we are going to have all the data, not just the public press release data that is given to us by the company. So after that meeting, I think I'm going to be much better informed about what all the data really are.
Give us some idea, Dr. Offit, how much data will you be reviewing?
Right. So the way it works is that the company submits their request for emergency use authorization, which is about an 80 to 100-page document. The FDA then reviews all the clinical data. This is roughly a 40,000 person study that was done. They're going to review all the clinical data and try and answer the question, was there anything that was not in that submission by Johnson & Johnson that we need to make sure that the FDA Advisory Committee knows about? That's another 80 to 100-page document. So we'll have a couple hundred pages to review. Usually we get that days in advance. The good news is that all those data are published on the FDA's website, so anyone can see them. Similarly, our deliberations on February 26th are all open to the public. You can live stream them. So it's a transparent process.
I've watched those hearings. They're fascinating. People ask some really tough questions.
It's good. And that's what you want. I mean, it's everybody that sits around that table at the FDA Vaccine Advisory Committee meeting is a vaccine skeptic. We want to make sure that these vaccines are, number one, most importantly, safe. And also highly effective, and to make sure that they're effective for all groups, meaning all age groups. And if that's not true, then the vaccine wouldn't be recommended for certain age groups, to make sure that it's true for all comorbidities, different racial and ethnic backgrounds, that essentially that their study looks like America, and that we can then feel comfortable recommending it for America.
Now, there have been great variations in countries around the world being able to vaccinate a lot of people. Israel is way out in front with its rate of vaccinated population, and yet they still right now are having a spike in cases. So vaccines are good, but they're not quite perfect, huh?
We also want to make sure in Israel that if they're using, for example, the Pfizer and Moderna mRNA vaccines, that they give both doses. Right now the push is to get as many first doses out there. Israel gets credit for giving a lot of first doses. Let's make sure that that they give those second doses, and then you can be comfortable that people are truly fully immune, and that their immunity will be not only complete but long lasting, meaning years. So when we get to that point, we'll see how things are playing out in Israel.
Now, what seems especially good news with regard to the vaccines is fewer deaths, less severe illness.
Yes, that's key. I mean, I think what you worry about here are the variants. So the virus that circulated in Wuhan initially in November 2019 quickly became a variant. And the variant either originating in China or originating in Europe, then sort of swept across the world. And so the first real, sweeping across the world of the virus was a variant. It didn't have a country name. It was just it had a letter and a number designation, D614G. But that's the virus that's prevalent in this country, that first variant. And that's the virus to which we all made a vaccine. These genetic vaccines like the mRNA vaccines or the replication defective simian or human adenovirus vaccines by J&J and AstraZeneca and the Russian vaccine are all sort of these directed against that strain. And so then other variants popped up. And what you worried about most of all, I mean, obviously you don't want it to be more contagious or more virulent, but what you really worry about is that it has escaped recognition by vaccine-specific immunity. That's what you worry about, because then you're talking about second-generation vaccines, and it's been hard enough just to get the first-generation vaccines out there. So the UK variant is essentially virtually identical to that original D614G, the one that was commonly circulating here. So that's not a worry. But then
when you say, wait a second, Dr. Offit, when you say, sorry for interrupting, when you say essentially identical, you mean in terms of how the vaccine works, right?
That's exactly right. So in other words, although there is one mutation, one critical mutation right in that so-called receptor binding domain region of the spike protein, which is kind of the business end of that spike protein, it's still similar enough to the strain that's commonly circulating, the first strain, that you don't really worry about it. And both in the studies done in the laboratory, studies down looking at antibodies generated from people who are naturally infected, antibodies from people who are generated from those who were vaccinated, all seems to neutralize that virus. So that's good. Then came the South African and the Brazilian strains, which are actually very similar to each other. And in the laboratory, when you took antibodies from people who were naturally infected, or when you took antibodies from people who were immunized, it seemed to neutralize this virus, or said another way, prevent this virus from binding to cells less well. In other words, it wasn't as good at killing this virus. So now people were worried. What was going to happen then when people were vaccinated? Was there going to be breakthrough illness? And so far that hasn't happened. That's what you're most worried about. You're most worried about the fact that there would be people who are fully vaccinated that nonetheless were hospitalized or killed by one of these variant viruses. Now, that hasn't happened. That line hasn't been crossed. And it also was similarly encouraging, at least in the Johnson & Johnson trial, as far as we know, in South Africa. But again, we're just reading press releases. It did look like it prevented very severe illness, meaning hospitalization and death. And that's good. That's really what you want. You really just want to keep people out of the hospital, out of the intensive care unit, and out of the morgue. That's really the main goal of this vaccine. Obviously, you prefer not to have mild illness or low moderate illness, but as long as these variants don't escape recognition regarding protection against severe disease, I think that's a good sign.
Now, South Africa discontinued use of the AstraZeneca vaccine against that variant B1351. That was a little alarming.
Yeah, and so again, all looking at press release information. One of the people who represented the Jenner Institute, in the United Kingdom at the University of Oxford, which did the primary research on this vaccine, said that this vaccine did still appear to prevent a very severe disease in South Africa. But again, there's no data. I mean, you're just sort of going by what people representing either the company or representing the research institute are saying without the data. So I don't know. I mean, if it was true that this vaccine didn't prevent not only against mild to moderate disease, but didn't prevent severe disease, then I can understand the South African Ministry of Health's decision to not give that vaccine because you have to do that. And, it's not exactly the same product. The UK is a replication defective simian adenovirus. The Johnson & Johnson is replication defective human adenovirus type 26. So they're not the same product exactly. And so there may be differences. But again, in my world, in the science world, you can tell whether there's difference when you read the details of publications, but you're not getting those publications. So you're just trying to read the tea leaves, which is hard.
Well, some people reading the tea leaves who don't have that kind of scientific expertise think, I am going in for my second vaccination, my second shot, and once that's done, I'm good to go. I don't have to stay at home. I don't have to wear my mask. Is that a fallacy?
Yes. First of all, although these vaccines, the mRNA vaccines of Pfizer and Moderna, are highly effective, 95% effective, that's not 100%. So that means that 1 out of every 20 people who get this vaccine are still not going to be protected. You might be that 1 in 20. Secondly, we don't know whether or not these vaccines, the mRNA vaccines, prevents infection where you don't have symptoms but still could be contagious. So there's 2 reasons still to wear a mask. One is the selfish reason. The other is an altruistic reason. The selfish reason is I might be the 1 in 20 who could still get sick. The virus is still raging in this country, so I'm still going to wear a mask and social distance. The altruistic reason would be, I still might infect others, so I should still wear the mask. And until this virus is under control, I think that's the wise choice.
You're listening to Dr. Paul Offit, director of the Vaccine Education Center at the Children's Hospital of Philadelphia. He's also the Maurice R. Hilleman Professor of Vaccinology and a professor of pediatrics at the Perelman School of Medicine at the University of Pennsylvania. Dr. Offit is the author of several books, including his most recent, Overkill, When Modern Medicine Goes Too Far.
After the break, find out how long we can expect it to take for the vaccination program to get us back to some semblance of normal life.
Should we balance our reasons for optimism against the possibility of reinfection in some cases?
Some people whose immune systems don't fight infections well may offer the virus conditions conducive to evolution.
We'll also consider the long-lasting emotional consequences of serious illness.
Then we'll talk with the coronavirus hunter, Dr. Ralph Barrick. Has he been surprised by the pandemic?
Find out just why masks work, especially if everyone wears one.
Dr. Barrick will also bring us up to speed on strains, mutations, and variants of this coronavirus.
You're listening to The People's Pharmacy with Joe and Terry Graydon. The People's Pharmacy podcast is supported in part by CocoVia Memory Plus. CocoVia cocoflavanols support both cardiovascular health and cognitive function by promoting healthy blood flow, transporting oxygen and nutrients to vital organs and muscles, including your heart and brain.
CocoVia Memory Plus has 750 milligrams of cocoflavanols, the plant-based nutrients from fresh cocoa that have been proven to help boost memory.
CocoVia Memory Plus is backed by 4 clinical trials that demonstrate improvement in 3 different aspects of memory: long-term memory, spatial memory, and word recall. The studies show improved brain function in just 8 weeks.
You can try the benefits of CocoVia Memory Plus with a 25% discount off your first month. Use the code PEOPLES25. To get the full benefits, take it daily for 8 weeks. Cocovia is offering People's Pharmacy podcast listeners a 10% discount on subscriptions. That code is Peoples10. Learn more at cocovia.com.
Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon.
The People's Pharmacy is brought to you in part by Cocovia, offering plant-based nutrients in the form of cocoflavanols for brain and heart health. Online at cocovia.com.
How long will it take for vaccinations to impact the spread of COVID-19?
Our guest is Dr. Paul Offit, Director of the Vaccine Education Center at the Children's Hospital of Philadelphia. He's also Maurice R. Hilleman Professor of Vaccinology and Professor of Pediatrics at the Perelman School of Medicine at the University of Pennsylvania.
Dr. Offit, there are a lot of people who assume that once they've had that second vaccination, they will ultimately be done. You know, the virus will eventually go away, not just for them, but for everybody, and that life will resume to be the way it was before the pandemic. How long will it take, do you think, for the vaccines to put an end to this virus?
First of all, it's a global problem. And we, this country, the U.S., is only as strong as the weakest country out there. I mean, we continue to give a polio vaccine in this country. We haven't had a case of natural polio in this country since the 1970s. It's been, 50 years since we've had a polio in this country. Nonetheless, we still give a polio vaccine. Why? Because polio is still endemic, meaning still circulating in Afghanistan and in Pakistan. And so because international travel is common, because polio, like COVID-19, is typically spread asymptomatically. Many people who are infected with polio don't know they're infected. They're not paralyzed. They're just shedding the virus. I mean, do I think people with polio could walk into LAX airport in Los Angeles or walk into LaGuardia Airport in New York? Yes. So that's why we continue to vaccinate. So I think if the answer to the question is what's going to stop our vaccination, I think it'll be when the world is under control, which is going to be a while. I think in terms of this country, I'm very optimistic, actually, and I'll tell you why. You're starting to see a decline in the number of cases and hospitalizations, and the question is that real? Now, it's February. I mean, it's winter. This is when this virus should be its most contagious. Yet the numbers are going down, and I think the reason is that there is enough natural immunity and vaccine-induced immunity that's causing somewhat of a decline. So for example, people say that roughly 27 million Americans have been infected with this virus, but that's just 27 million people who have been tested and found to be infected. Not everyone gets tested. In fact, many people who are asymptomatically infected or mildly infected don't get tested. So the only way to know the real number of people in this country who've been naturally infected is to do antibody surveillance data, see who's been exposed to the virus. When you do that, you find that 27 million number is off by a factor of at least 3 and possibly 4. So that's 75 to 100 million Americans who've already been infected. That's roughly 25% of the population who basically is immune. Plus, we have more than 40 million doses that are out there. And although most of those are just single doses, meaning they haven't completed the 2-dose series, there is some protection from that first dose. That's another 10% of the population, that 40 million. So now you're talking about, 35% of the population, really a third of the population, which is to some extent immune. And I think that with polio, for example, to go back to that example again, once we got to about 40% immunization rates with polio, you started to see some decline in polio. And I think, which was similarly contagious to this virus. So I do think that what you're seeing now is real. And I think it is based on natural and vaccine-induced immunity. So, we've given 1.5 million doses of vaccine a day. If we can get up to 3 million, I really do think we can get control of this virus by the summer.
I do want to ask you, Dr. Offit, about the possibility of reinfection. What do we know about that?
Well, I think it's likely you could be reinfected. There are many vaccines out there on the market now, like the rotavirus vaccine or the whooping cough vaccine or the influenza vaccine or the pneumococcal vaccine, where you can get reinfected. But the issue is that you're not symptomatically or at least severely symptomatically reinfected. So I think we're going to continue to be exposed to this virus for a while. If you've been naturally infected or you've been immunized, I think you're relatively protected. So for example, what you really worry about with this virus when it first started was, does natural infection protect? Because that's not true of all germs. I mean, you can get strep throat over and over again. You can get gonorrhea over and over again. There's no evidence that natural infection protects against disease. That's a problem. So that's the first thing you wanted to see. Does natural infection protect? Are people who've been known to be infected, are they then, when they're exposed, are they severely symptomatically infected? And the answer was no. Great. Now you can just mimic the immune response, that's induced by natural infection. And that's basically what we've done. Dr. Fauci was on TV the other day saying that in South Africa, people have been shown to be infected twice. But when you look closely at that second infection is much milder. Fine. That's what you want. So I think there will be reinfection, but hopefully it won't be severe symptomatic reinfection.
Dr. Offit, there was a fascinating article in the New England Journal of Medicine, and NPR reported on it recently, in which people who are sick for a long time, not just for a week or two, but maybe for a month or two or more, who are also somewhat immunocompromised or who have received immune suppressing drugs, may become, if you like, petri dishes for mutations. That is to say, their bodies may allow variants to develop faster and in more profound ways. Is there anything to that?
Yes, I think there is. I think that when the way that you create, for example, so-called escape mutants or variants in the laboratory is that you take a virus and then you sort of weaken it, meaning you give it, you expose it to antibodies that sort of weaken it, cripple it, but don't kill it, which then gives it a chance to kind of rehabilitate itself in a different form. The situation that worries me the most in this is that there have been a number of people who've been on national television talking about how we need to get as many first doses out there as possible. Well, if you look at these two mRNA vaccines, the second dose gives you a much larger, much broader, much higher titered neutralizing antibody response, a much better neutralizing antibody response than just the first dose, and you get immunological memory with that second dose, so it's going to be longer lived. I think that if we have a lot of people out there who just get one dose and don't come back for the second dose or unable to get the second dose, that's the way to create variants. So I think that's what worries me in this a lot.
Dr. Offit, you're involved in overseeing vaccine approval. You're on the FDA's advisory committee. There's a lot of talk about developing new boosters in the event that we develop these variants that require an extra shot. Will the FDA review of the booster take as long as the original vaccine to approve?
Well, so I would actually, it's not taking that long to approve this. The typical length of time it takes to approve a vaccine, at least the licensed products, about 10 months. So that, that J&J, for example, has just submitted and is probably going to find out whether or not they have an approved vaccine within a matter of a few weeks is actually remarkably fast. And you want the FDA to really seriously review all those data, because we certainly don't want to put a vaccine out there that in any way would be unsafe. But I think what you're getting at, probably more importantly of what you're getting at, is that if for example, we needed a second generation vaccine, let's say that there was a variant that came out in this country that now was resistant to vaccine-induced immunity. How quickly could we get that next vaccine out there? Do we have to do what was just done for Pfizer and Moderna's vaccine, where we do these months-long sort of so-called phase 3 efficacy studies that involve tens of thousands of people? No, that won't happen. I think that the more likely scenario, it'll be more like the flu vaccine model, where you'll test your new product in hundreds of people to make sure that it's safe, to make sure that it's inducing an immune response, but you're not going to do those big phase 3 studies. And then the vaccine would be approved in the same way we really approve flu vaccines every year.
Dr. Offit, I have a personal question for you. We've talked before about the fact that we both, as children, spent time in polio wards. I actually had polio. You were put there for other reasons because of surgery. I discovered that I probably had what we now call PTSD, post-traumatic stress disorder, as a result of my hospitalization, getting to wait for a week to see my parents through a tiny glass window in a door at Philadelphia Children's Hospital for at most an hour, and just feeling really abandoned. I was so young, I didn't really know what was going on. And I suspect that you had somewhat similar experience. What do you think the impact of the COVID-19 infections will have on people who have spent a lot of time in hospitals and who have been very sick going forward?
No, I think we're already seeing that. I mean, all this sort of long hauler phenomenon, where people have chronic symptoms, I think is probably many different things. But one thing it might be is sort of an ICU psychosis in a sense that, this is the consequence of being on a ventilator for a long period of time or in an ICU for a long period of time. No doubt about it. And in terms of scarring, I like you, was definitely scarred. I mean, there was one moment where I had to go back as a medical student to that chronic care facility, which was then, when I was growing up, called Crenane Crenane's Hospital for Crippled Children, back when they used to use words like crippled and feeble-minded. And when I went into that hospital, the room where I had stayed, the polio ward wasn't a ward anymore. Obviously, it was just a group where a lot of secretaries were sitting in cubicles. But the window that I looked at when I was in that hospital was still there, and it still overlooked the front door. And my parents didn't come. Though my father was sort of thrown out. My mother was sick with her pregnancy with my brother, and I walked up to that window and looked out that window that I'd looked at for 6 weeks when I was in that ward, and just wept. I mean, it scarred me. And my mother said that when I came back after that episode, I just insisted on staying in their bed, and I didn't talk, and I was depressed. And I'm sure that affected my life.
Well, the not talking rings a bell for me, because when I had to go back into the hospital a couple of years later for surgery, my mother had to lie to me to get me to go back to the hospital. And I stopped talking to her for at least a week after that. I was like, I don't want to have anything to do with you. You put me back in the hospital. So, yeah, it was a traumatic experience for sure. I sure hope that a lot of the people who have gone through COVID, severe illness, don't have to go through as much trauma as you and I have had to put up with.
It is better days now, is the good news. I mean, you have, for example, in our COVID ward at Children's Hospital Philadelphia, there's iPads. So we can talk to people, through their iPads, and there's televisions, and there's, the parents can certainly stay in that room. I mean, it is a different time.
Dr. Paul Offit, thank you so much for talking with us on the People's Pharmacy today.
Thank you. It was my pleasure.
You've been listening to Dr. Paul Offit, Director of the Vaccine Education Center at the Children's Hospital of Philadelphia. Dr. Offit is the Maurice R. Hilleman Professor of Vaccinology and Professor of Pediatrics at the Perelman School of Medicine at the University of Pennsylvania. Dr. Offit has written several books, including his most recent, Overkill, When Modern Medicine Goes Too Far.
We turn now to the coronavirus hunter, Dr. Ralph Barrick. He's the William R. Keenan Jr. Distinguished Professor in the Department of Epidemiology and Professor in the Department of Microbiology and Immunology at the University of North Carolina at Chapel Hill.
Welcome back to the People's Pharmacy, Dr. Ralph Barrick.
It's an absolute pleasure to be here again today. I hope you both are doing well.
We are, thank you.
We are. We both have received our second vaccine, so we're feeling a little bit calmer than we have been for the last year. And speaking of the last year, Dr. Barrick, you've been studying coronaviruses for decades. You probably know more about this class of viruses than very many other people in the world. As you look in the rearview mirror, have you been surprised by the way this pandemic has evolved, or did you anticipate what took place?
Well, I think it was very clear on the 25th of January, 2020, when the health minister of China said that there's clear evidence of asymptomatic spread and community spread, and that they thought that there was airborne transmission. And so once you hear those words, and you know that you have a highly pathogenic respiratory virus, it's going to become very, very difficult to stop the spread of that pathogen around the world unless the population is committed to wearing masks, to social distancing, and paying very close attention to sort of personal hygiene and being prepared. And in many cases, in many instances throughout the world, there's just no way that you can implement those types of preventative measures because they don't have masks. They live in crowded conditions. And so the virus is going to spread through those populations unabated. Yeah, so yes, I did expect it.
And now, Dr. Barrick, we obviously do have access to masks. Most people do. But there were a lot of instances in which Americans didn't actually understand why they should be using masks. Can we just go back over how masks work and why they work best if everybody's wearing one?
Sure. So in a variety of studies, mostly looking at influenza and other common respiratory viruses, which would include the common coronaviruses, wearing a mask has been shown by Alison Aleo, for example, here, a researcher in the Epi department at UNC, and many other researchers, to be 40 to 60% effective at reducing the chance that you're going to become infected. If you have two people wearing a mask, both wearing masks, then the protection goes way up. And it protects in two ways that people need to understand. The first is, in many cases, it'll filter out viruses and prevent you from being infected. So that's straightforward. The second one is a little more complex. And when people become infected with a virus, the dose that they receive can have a big impact on how severe the disease is. So, for example, one person receiving a droplet with 10,000 virus particles in general would be more likely to get more serious disease than one that received 10. And so a mask helps filter out the initial dose that a person receives, and that can then result in less severe disease. And so those are the two reasons why it's a good idea to wear a mask. And in countries that have implemented it aggressively, it's worked.
Dr. Barrick, this virus is, I think, very confusing to people. They've heard terms such as variants, mutations, strains. What's the difference, and what do you anticipate over the next several months and even years when it comes to these variants and the vaccines?
Well, maybe an easy way to think about it is that when RNA viruses replicate, these are viruses that have an RNA genome, a messenger RNA genome in the case of coronaviruses. Their enzymatic machinery that produces more and more viruses is error prone. And so they make mistakes. They don't make mistakes super frequently, but every 1 in 10,000 to 1 in 100,000 bases, they'll make a mistake. And that will result in a mutation in the viral genome. Many of those mutations have neutral effects or they're deleterious. And so those kind of strains, there's no selective advantage of them. And in many cases, it's deleterious. And so they can't compete as well and they go extinct. But every once in a while, especially when more and more people are infected across the planet and you're making more and more mutants, you'll get an advantageous mutation. And that mutation can enhance its ability to grow. It can enhance its ability to transmit, or it could enhance its ability to escape antibodies that were made in people that were infected with the ancestral strains. And so they can reinfect that individual. And so mutations occur all the time. Variants would be mutations that have occurred that are now amplifying in the population and showing, in other words, they have advantages. We don't know what those advantages are, but they have an advantage because they are increasing in incidence and spreading globally. And strains is a word that captures the broader category. For example, SARS coronavirus 2 is a strain. It has variants and it has mutants. That's how I understand it.
You're listening to Dr. Ralph Barrick, the William R. Keenan Jr. Distinguished Professor in the Department of Epidemiology and Professor in the Department of Microbiology and Immunology at UNC Chapel Hill.
After the break, should we worry about reinfections with new variants of COVID-19?
What other coronaviruses should we watch out for so we can prevent the next pandemic?
You're listening to The People's Pharmacy with Joe and Terry Graydon.
This podcast is brought to you by Verizana Health Club. This comprehensive home testing service enables you to track crucial health markers of gut health, inflammation, metabolism, hormones, thyroid function, and many other organ systems. Regular testing can help detect health imbalances before they lead to illness. Online at Verizana.com. That's Verizana.com/health-club. Get 50% off the first month with the discount code PEOPLE50. That's PEOPLE 50.
Welcome back to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon.
The People's Pharmacy is brought to you in part by CocoVia Memory Plus, a supplement with 750 milligrams of cocoflavanols, the plant-based nutrients from fresh cocoa that help support memory. More information at cocovia.com.
Also by Verizana, an analytical laboratory providing home health tests for hormones, gut health, and the microbiome, now with an annual health club plan. Online at Verisana.com.
We're talking about new developments related to COVID-19. How well will vaccines protect against new variants? What about new drugs to treat the virus?
Our guest is Dr. Ralph Baric. He's the William R. Keenan Jr. Distinguished Professor in the Department of Epidemiology and Professor in the Department of Microbiology and Immunology at the University of North Carolina at Chapel Hill. He spent the past 3 decades as a world leader in the study of coronaviruses.
Now, Dr. Baric, you mentioned reinfecting people who have already had antibodies to the original version. Is this happening? Is it something we need to worry about?
The short answer is it's still under study, but I think the answer is yes. So again, you have to think about how people respond to the initial infection. And one of the key correlates of protection, at least in animal models, is how high your antibody titers are that neutralize the virus. Neutralize meaning when the antibodies in your serum or in your secretions bind virus, they kill the virus. And so one of the things that's been documented over and over again is depending on how severe your infection is, that's a direct correlate with how high your titers are, your neutralizing titers are. So somebody who has a very mild asymptomatic infection may have really low titers. Let's just say for your audience that it's 1 to 100. In other words, you can dilute your serum in blood 1 to 100-fold, and you can still neutralize virus, half of the viruses in an assay. Somebody who gets severe infection may have titers of 1 to 1,000. So you could dilute their serum 1 to 1,000, and that would still neutralize half of the viruses in the plate. Now a variant comes along, like the South African variant, and all the data suggests that the South African variant reduces your neutralizing titer efficacy by about 6 to 10-fold. So now the person, let's say in this case, in these two individuals, it's 10-fold reduction because I can do the math in my head. So now the variant comes along, and the person who had the mild infection, their neutralizing titer now is 1 to 10 against the variant. The person who got serious infection, their neutralizing titer is 1 to 100. And the data in animal models suggests that somewhere around 1 to 50, to 1 to 100 neutralizing titer is effective in providing some level of protection. So one individual now is below that. One individual is at that level. And so that can allow for reinfection. In one case, with very little protection in terms of antibodies, and in the other case, pretty good protection. And so how does that correlate with outcome? The best we know now for the South African variant, which has the biggest phenotype on neutralizing antibodies, is that the variant can break through and cause infections, but that people aren't experiencing life-threatening disease in most instances.
Dr. Baric, we were just speaking about variants of the coronavirus and in particular the South African variant. And I'm wondering about vaccines because I think right now there's tremendous concern that maybe the vaccines won't be as effective against some of the variants, like the South African and the Brazil variant. What's your readout?
Well, the London variant has about a twofold reduction in neutralizing titer, and so I don't think it's going to be an issue in terms of its current genetic status. The South African has been well documented in terms of the effect of that variant on your neutralizing titers, 6 to 10-fold, and the Brazilian isolate I think is still under study. It may not be as much as the South African variant, but I think we'll know the answer to that more definitively in the next couple of weeks. It's probably going to be more than London. Whether it's more than or equal to the South African, I think, is still being heavily investigated.
Let me ask you about herd immunity. We've heard about the goal of reaching herd immunity by vaccinating as many people as we possibly can. Is that a realistic goal?
Well, sure. We achieved that goal with the measles vaccine, and viruses themselves achieve that goal by infecting enough people so that herd immunity occurs within a population. So it's quite possible that we can do that, but it's going to be dependent on how quickly the vaccine can be rolled out to the whole world. And right now, what you're going to see are pockets of herd immunity that occur by one of two mechanisms. One is by natural infection. And so where the South African variant and the Brazilian variant emerged, the data suggests that, the seropositive rates in these regions were approaching 70%, very high dense populations without access to protective gear. Elsewhere in the world, we're, ranging, depending on location, 10 to 20% seropositive rates, with focal areas where it will be much higher. And it's in these regions of high protective immunity, 40, 50%, where variants start emerging. There's enough selective pressure for viruses that can escape that immunity. And so, again, that's a key reason why we need to get vaccine distributed globally as quickly as possible to prevent variants from emerging that would then be able to outcompete and result in vaccine reformulation.
Dr. Barrick, we're wondering about drugs to treat COVID-19. So many people who have become ill, if they become very ill, they land in the hospital, and our armamentarium is pretty limited. Has it expanded over the course of the last year?
Well, in the U.S., the FDA just recently gave approval for remdesivir in combination with baricitinib, which has it's modest, but it's improved over remdesivir alone in terms of time to recovery and some other disease characteristics. So that's a little bit of an improvement. Therapeutic antibodies delivered after about day 6 or day 7 don't work, but prophylactically or given for early in infection, they are very, very, very effective.
Well, I think a lot of us remember former President Trump basically talking about the monoclonal antibodies as a miracle treatment. And of course, he did get it very early.
That was the key. He got it very early, probably on day 3. And he probably, the timeline's a little bit difficult to follow there, but he either got it on day 3 or day 4 for the antibody, and day 4 or day 5 for remdesivir. Most people don't get remdesivir until around day 7 when they get admitted into a hospital where they can be put on an IV drip.
Well, Dr. Barrick, there have been a lot of suggestions that we've put all of our eggs in the vaccine basket for the most part, and the antiviral research has been kind of in the backseat, hasn't gotten the same degree of enthusiasm. And I'm wondering about some of the drugs. You were involved in the development of remdesivir, but what about a drug that's called, and I don't know how to pronounce it, now it's molnupiravir. It was known as EIDD 2801. That's a drug that you're familiar with. It would be wonderful if we had widely available antivirals that as soon as people had the first inkling that they might have come down with the virus, that we could stomp on it before it had a chance to take hold.
Yeah, so that's called preparedness. There are 2 ways you can respond to a pandemic. One is reactive, and the other is more of a preparedness platform where you know it's coming, you know it's going to come sometime in the future, and so you say, okay, I want a drug on a shelf that's ready the day it happens. Drug manufacturers generally can't make money that way, so their interest is less poignant. Although, for example, in the case of Gilead, they were very interested in developing remdesivir as a drug on the shelf for future pandemics. And so they were somewhat supportive of our collaborations there. And remdesivir, again, it's not a super home run, but it has it's saved lives. It's made a difference in duration in the hospital. But its weakness, again, is it has to be given by IV. And we started working with that drug around 2015 or 14 or so. And we're moving towards an oral delivery platform, but the pandemic occurred before that happened. It's still being actively studied and more aggressively studied now at Gilead. Hopefully something will be available soon where you could take a pill as soon as you were diagnosed in an outpatient setting. Molnupiravir, or Thor's hammer, is a drug called EIDD 2801. We were studying that one extensively prior to the 2019-2020 pandemic, and in fact published a paper in March of 2020 showing the effectiveness of that drug against SARS-2 and every other coronavirus that we had in our laboratory as a broad-based inhibitor. The advantage of that drug is it's oral, and that what was called pre-IND data, or the animal data that we had, was inserted into a package that went to the FDA to allow for phase 1 testing in England, and it's currently in phase 2, phase 3 testing in the United States and elsewhere, including one outpatient setting here at UNC.
Dr. Barrick, you have been studying coronaviruses for over 30 years. We've dealt with SARS-1, if we can call it that. Now we're dealing with SARS-2. Are there other coronaviruses we should be concerned about? Are there other what we'll call zoonotic infections? That is to say, infections that jump from animals to humans that could be on the horizon. How do we prevent another pandemic?
So, obviously, there is another epidemic or outbreak human coronavirus that's coming out of zoonotic reservoirs, and that's MERS coronavirus in the Middle East and in equatorial Africa. It hasn't figured out how to be transmitted efficiently between people. But there are people who appear to be super spreaders that can spread to multiple people, and what the biological basis of that is not really clear. We know that the zoonotic reservoirs, in the case of the SARS-like and the MERS-like coronaviruses, are filled with other similar coronaviruses that are capable of using the human receptor, that are capable of replicating as efficiently as these epidemic strains in primary human lung cells. And in mice that express the human receptor, these viruses can kill the animal. And so we know that there are what are called pre-epidemic strains that are perfectly positioned to spill over and replicate in humans. We don't know how well they could transmit, but we know that there's no reason why they couldn't replicate in people if people come in contact with them. And so, as human population increases to 7.5 billion, or I'm not exactly sure what the number is, somewhere around 7 billion people, let's say, the interface between wildlife and human is becoming more and more abrupt and dense. In other words, so you have bat caves with millions of bats that are coming and in very close proximity to millions of people. And that is perfect conditions for virus spillover. In many cases, in rural settings, for example, there's also large numbers of domesticated animals, either for raising for the people in the city or for the personal consumption, that can serve as reservoir hosts for spillover. And so the prediction would be, we've now had 7 zoonotic viruses spill over as human coronaviruses. including the 4 contemporary strains and the 3 emerging strains. We know that there are phylogenetic groups within coronaviruses that are huge, very, very different than any of those other strains, and we know nothing about them in terms of their potential. We know that both SARS and MERS-like bat coronaviruses are filled with strains that can replicate just fine in human cells. And we know that there's a large number of other similar zoonotic viruses that can replicate in human cells that are causing animal disease. And so the truth is, I don't think, and I think most people would probably argue the 2 biggest threat viruses on the planet really are influenza and coronaviruses in the 21st century. And, we've had 3 new coronaviruses emerge in the last 21 years. That's on average every 6 to 7 years. We've had 3 emerging coronaviruses in swine populations in the 21st century. That's the same rate that's occurring. Whatever ecologic niche has been triggered apparently has been triggered. And so we can expect future emergence events from zoonotic reservoirs, I think, in the 21st century.
Dr. Baric, we have just a minute left in our conversation with you. Where is your research focused going forward?
Well, we're focused on a lot of different things. Animal model development to understand both acute and chronic disease manifestations that occur, and so that those animal models could be used for testing more drugs. And we're actively working with about 6 or 7 companies. So I just take a little bit of exception to the idea that there hasn't been a focus on drugs. It's just hasn't. It's not as focused a target in terms of as vaccines were. It's a harder target. There's a lot of work on drugs. The second thing that we're doing is we're heavily involved in the vaccine front in terms of vaccine design and testing and universal coronavirus vaccine design. We've been involved in identifying antibodies, some of which are already in the clinic, some are moving toward the clinic as therapeutic antibodies. So we've been involved in that. We've been studying new variants as they come along and what their pathogenic and biological features are, and also doing sort of fundamental studies into terms of what cell types in the human lung are targeted by the virus and what's the consequences of those infections. So we're doing a lot of work on all fronts of SARS-2 coronavirus 2.
Dr. Ralph Baric, thank you very much for talking with us on the People's Pharmacy today.
Okay.
You've been listening to Dr. Ralph Baric. He's the William R. Keenan Jr. Distinguished Professor in the Department of Epidemiology and Professor in the Department of Microbiology and Immunology at the University of North Carolina at Chapel Hill. He's a Harvey Weaver Scholar from the National Multiple Sclerosis Society and an established investigator awardee from the American Heart Association. Dr. Baric has spent the past 3 decades as a world leader in the study of coronaviruses and is largely responsible for UNC Chapel Hill's leadership in coronavirus research.
Lynn Siegel produced today's show. Al Wodarski engineered. Dave Graydon edits our interviews. B.J. Liederman composed our theme music.
The People's Pharmacy is a co-production of North Carolina Public Radio, WUNC.
The People's Pharmacy is brought to you in part by CocoVia Memory Plus, a cocoflavanol supplement backed by 4 clinical studies that show significant improvement in 3 different aspects of memory. More information at cocovia.com.
If you'd like to buy a CD of today's show or any other People's Pharmacy episode, you can call 800-732-2334. Today's show is number 1247. The number again, 800-732-2334. Or find it online at peoplespharmacy.com.
When you visit the website, you can share your thoughts about today's show. What further questions do you have about the vaccines and the variants?
You can subscribe to our podcast through your favorite podcast provider. We post the show on our website on Monday morning. You might want to share it with a friend.
At our website, you can sign up for our free online newsletter to get the latest news about COVID-19 and other important health stories. In Durham, North Carolina, I'm Joe Graydon.
And I'm Terry Graydon. Thanks for listening. Please join us again next week. Thank you for listening to the People's Pharmacy Podcast. It's an honor and a pleasure to bring you our award-winning program week in and week out. But producing and distributing this show as a free podcast takes time and costs money.
If you like what we do and you'd like to help us continue to produce high-quality, independent healthcare journalism, please consider chipping in.
All you have to do is go to peoplespharmacy.com/donate.
Whether it's just one time or a monthly donation, you can be part of the team that makes this show possible. Thank you for your continued loyalty and support. We couldn't make our show without you.